Hi, and welcome to your Gonadotropin um, lecture regarding hormones and exercise. As been the theme or the trend with all these video lectures so far, we'll get into the standard physiology, a bit of anatomy regarding these specific hormones, and then um, tie them into exercise and the effects of exercise, or I guess in this case, how these hormones might affect how we perform certain exercise or physical activity as well. So, gonadotropins are hormones produced by the gonads or sex glands, sex hormone glands. So, in women, we're gonna need to look at these at both like women and men as well. So, in women, we have luteinizing hormone that acts on the ovaries, and follicle stimulating hormone that acts on the ovaries as well. Both are utilized for ovulation and to different effects there. Okay. In men, our luteinizing hormone and follicle stimulating hormone are still present, and I think that's important to note as well. So, keeping in mind that testosterone, as well as in both men and women, just at different amounts and have different effects. Similarly, estrogens are found in both men and women, but again, just in different amounts and have different effects and use at different time during development. So, just as some background there too. So in men, luteinizing hormone acts on Leydig cells of the testes, so they produce testosterone there. But follicle stimulating hormone doesn't have a completely different purpose as stimulating ovulation, but in the testes for men, where it helps in sperm production as one of its main roles. Okay. So to kind of give you an idea of what I was kind of speaking about. So again, we have men and or male and female bodies here depicted, and again, very similar release of gonadotropin releasing hormone being released from our hypothalamus to the anterior pituitaries of both male and female pituitary glands, and that causes the release of luteinizing hormone and follicle stimulating hormone. That's a tricky one for me tonight. But they have end effects slightly different because of their target organs, testes in men and ovaries in women, but both end up releasing some testosterone and inhibin, which go back and cause a negative feedback loop on the hypothalamus and the pituitary gland. So again, keeping note that our hormone systems are kept in balance and homeostasis because of this negative feedback loop. Okay, so we have positive feedback causing the release of things, but then get a negative feedback from the end products to discourage continual production of. I think of important note, because we don't have very many of these in our body, is depending on where women are within their ovulatory cycle, some of this will lead to a positive feedback to cause more secretion. So again, typically we have negative feedback loops in our body. This is one of the exceptions where we have a positive feedback loop. Okay. So we also have androgens, and typically, so most common and most known, it's testosterone. So looking at men to begin with, testosterone, again, is synthesized in the testes, and it's one of the most potent anabolic hormones for men in particular, but I would think there's some research to support in women as well. But I digress. So it mediates the development of masculinization, of the brain for during development. So as men are developing, and I think one note of research behind this So there's lots of research out here about uh, the male and female brain and what differences exist between the two. Psychology in particular has really dove into this field, but I feel, or my understanding is anyway, that as far as the biological structuring, there seems to be, from what we can ascertain from MRI studies and such, that there is some differences between men and women's brains, or male and female brains. And I think the one good part about this today is, I think it provides some backing or evidence for trans individuals who truly feel that they're not in their right gendered body. And I think research behind some physiological findings where people's brains, in trans individuals as well, do show that, for example, their brain may be set up or develop more like opposite gender than the sex body that they are in. So I think it's interesting to look at the differences between male and female brains, for sure. And testosterone is one factor that weighs into that, but clearly not just the end all be all, as our brains are very complicated organs. Moving forward, I think, and what we're most familiar with testosterone is building muscle, bone. So through those, increased strength, and testosterone is related to libido for men. So part of this, and I think this point leaves it incomplete. Builds muscle and you get strength. So I think the key point to take away about testosterone is that it's vital for recovery and repair of tissues. And, I putting it in the context of doping. So if you're to take testosterone, I think what perhaps the general public might miss is that a lot of athletes that dope still undergo very high intensity and high volume training, depending on their sport and what they do. But the key difference is, or the where doping comes into play, is that the expedited repair and recovery that testosterone facilitates, that's where you get the benefit from. So again, it's not like you can start injecting testosterone and just expect results from doing nothing. And the side point of this too as well is something to do with biohacking, where people use CRISPR technology, which is just this way of creating a genetic code based off of what you want, and then you essentially deliver it into your body. And biohackers in particular are a bit of libertarians and feel like they should have complete freedom over their bodies, and so some choose to try to self modify their genes. And I'm not, because they operate typically outside the realm of ethical science by nature of their belief system. I think there's no real good research to show that what they've done so successfully. But even in this case, so one example is they inject a gene that increases or makes more readily available building muscle. Okay. So they've isolated a gene for this. So you can inject yourself with that and try to, through like gene therapy, alter your genes to be able to put on more muscle. The individual in particular that I have in mind that's claimed to have done this didn't really see any results. And I would speculate that one of the issues behind that is he probably didn't also spur on a lot of, one might not have created enough stimuli through exercise to actually get muscle development. So again, similar with testosterone, if you're supplementing with that, which I don't suggest doing because of the side effects and adverse health effects, you also need to do the work. So I think, again, the short version of that whole side tangent was there is no shortcuts, even in doping. The work still has to get done. So again, along those lines with recovery and repair, what you see with testosterone is increased protein synthesis, increased, and we get that primarily just naturally if you start resistance training. Okay, those values go up at like a resting level. So again, you do your exercise, you repair, you recover, testosterone levels will increase and they'll stay elevated even when we're at rest. So we don't have to actively be exercising in order to have these higher levels. But one thing to keep in mind is with endurance training, because you often hear this, that if you do aerobic work, you're going to lose all your strength gains. And as far as testosterone is concerned in building muscle, that's really not the case. So what will tend to happen is there will be no change or decrease in testosterone levels with endurance or aerobic type training. In fact, some types of what might be considered aerobic training, say like high intensity intervals, you can find some increase in testosterone from that form of exercising. Okay, so with women during exercise or with exercise, we'll come to find that resistance training does increase testosterone levels a little bit, but the significance level is a little bit up for debate. And the response that women have to testosterone levels appear to be much less receptive than in men. Okay. And so one of the ways that testosterone acts quickly, in particular with men, is through its structure. So steroidal-based hormones, primarily arising from cholesterol. That's why we need a little bit of healthy types of cholesterol in our nutrition and our diet. But we get progesterone, which is a hormone that women use within their menstrual cycle. Cortisone, aldosterone, cortisol. We spoke about cortisol as an adrenal hormone. Same with cortisone. Testosterone, and then we have our estrogen-based hormones as well here. So they all derive and originate from cholesterol. And if we recall back to the mechanism at which that steroidal-based or cholesterol-based hormones work, is they can essentially enter straight into the cell, where they then start mediating and upregulating our genes for some sort of, let's say, protein synthesis of some kind, depending on what group of steroidal hormones we're speaking of. Okay. So we spoke about androgens. Now we can move forward to estrogens and the menstrual cycle. Now, we'll go through the physiology generally behind this, but then we'll get into more so how this might affect exercise, or exercise might help women with the menstrual cycle. Okay. So menstruation is a monthly cycle, typically, but on average, depending on where you are in your development, it can last different days, as well as just in your life and lifestyle choices that can influence the length of or changing of menstrual cycle. And so on average it's 28 days, which is about a month, but it has a bit of a range, right? And ultimately, again, luteinizing hormone stimulates the release of estradiol, which increases uterus lining, which helps prepare the body, women's bodies, for carrying a child or becoming pregnant each month. And I think that's so again, that's the menstrual cycle as an overview. for this component, you don't need to memorize all of it exactly, but something to keep in mind is the ovary produces the ovum or the egg or the oocyte, and right around mid-cycle, that's when typically we're most fertile, or women are most fertile. When, if fertilization doesn't occur, what we'll have is expulsion of the secondary oocyte, and we have a corpus luteum that ends up being shed during ovulation. And I guess I think I missed this point, but the whole point of the menstrual cycle is to build up the endometrium wall, which essentially makes this very like supple, like fertile lining for potentially a fertilized egg to become embedded on. And what the endometrium ends up becoming is the umbilical cord and this integrated kind of blood network where nutrients and oxygen, gas exchange can occur for the developing embryo and fetus. Yeah. And so once ovulation or menstruation occurs, menstruation is like the bleeding component of the menstrual cycle. Essentially, you're shedding this lining, which you can kind of see here degrading, and then after the menstrual phase, you rebuild it up. So, that's kind of the general monthly cycle there. There's some things to keep in mind, and conditions where, for if you're working with female athletes or women athletes, there's a few different things that can come up. So dysmenorrhea, sorry for the symbol there, is painful periods with severe cramping. Amenorrhea, which is a lack of a menstrual period. And I think, so there's lots of possible causes: pregnancy, breastfeeding, extreme weight loss, eating disorders, stress, excessive exercise. But I think excessive exercise in the context as a coach is, well, all of this is very important when you're trying to consider what's going on with your athlete. So if you find out one of your athletes isn't having a menstrual cycle or menstrual period, definitely a point in time to maybe have a conversation with them, see if you can see if they can open up to you, and you can kind of find out a little bit more what's going on with them, or a client, or whomever you're working with. Because again, if you're the one programming an exercise program for your female clients, it's really important to know if there's some sort of excessive exercise going on, or some sort of eating disorder, or lack of nutrition on the other end of that. Because it's important to consider. Menorrhagia is prolonged menstruation bleeding, sometimes usually associated with clots, blood clots, and then there's premenstrual syndrome, which a lot of us have heard of as PMS, but any side pop culture side references to it, I think, is needed for special consideration in and of itself. So it's highly variable with the types of symptoms that might display, so it's very individualistic in that sense, and it's 7 to 14 days prior to the period. But I think what's important to consider, or note anyway, as far as exercise and exercise influence on this, is that sometimes exercise can diminish the symptoms of PMS. And it says the effects on performance is variable, but I want to get to the performance aspect in a moment. So I think an important note about easing or reducing symptoms of PMS and exercise, and noting how individualistic it is, I think two things kind of occur. This is definitely a multifactorial thing, and that's why, as an individual, I think, from what I've heard from my female and women clients and friends and stuff, is yeah, it can vary from cycle to cycle, although you get to know your body over a while and you notice trends that typically occur. But one of the things, as far as trying to utilize exercise as a means of reducing symptoms, typically what needs to happen is some sort of base built up of physical activity and exercise before trying to reduce symptoms specifically with exercise. And so some of the ways this happens, again, depends on the symptoms that one would endure or feel during PMS, but things like endorphins and just moving the body where you might have aches and cramping sometimes helps for some individuals. But that being said, other times for some women, the cramping and pain and discomfort associated with PMS is not conducive to exercise. So yeah, I mean, that's kind of explaining a very variable thing, but I think one of the other important notes to come up with if you're thinking about programming for a client or an athlete who is a woman or female, I think one of the things to consider as well is the workload in and around this around a menstrual cycle. So typically, because of most of the coaching, this is just a personal anecdote to kind of help explain it, but things like I've noticed this with weightlifting and fitness-based clients, as well as triathlete or triathlon-based, so endurance activity athletes. And usually when the training volume gets quite high for an endurance event, in and around the time that these individuals have their periods, a large percentage of the time I start getting feedback where we need to reduce training load during that time. So an approach that you can take as a coach is essentially trying to plan a recovery week or a taper week in and around time of menstruation, just to give your athletes or clients a break around that point in time, because everyone's responses are so individual. So listening to that feedback about your individual client or athlete is really important. Okay. That was the gonadotropin hormones. Again, that's both for men and women. And just as a reminder, both men and women have these hormones in their bodies. They're just at different levels and have different net effects.